Let's solve question 12 on this sample Avogadro contest. This is a classic stoichiometry mole ratio problem, so a very foundational concept in chemistry. So we're given a balanced chemical equation and we're being asked to determine how many grams of B2H6, so that's my product, how many grams of the product can be made if I started with 5.00 grams of my reactant LiAlH4. It tells me in the question that the other reactant, BF3, is excess. So I don't really need to worry about this reactant because the limiting reactant is the one that determines my products. So that's actually this one, okay, the one that I have data for. The excess one is going to be extra, so that does not determine how many products I will make. So I actually did a calculation in advance. What I did is I turned the mass of LiAlH4, I turned that into mole using my mole equation N equals m over m. So I used my periodic table on the Avogadro contest to find the molar mass, and I converted the reactant into moles, which is 0.1319 moles. Okay, so that's fine. What I need to do now is go to my product side and figure out what's the mass of this product B2H6. So to get the mass, which is my m value, I'm going to need the molar mass, which I can get off my periodic table, but I also need moles. So I'm going to need to know how many moles of product do I have, so I can use a mole ratio to figure that out. So this is how I like to set up my ratio. I'm going to take the moles of my reactant, my limiting reactant, which is 0.1319 mole, and I'm going to record the compound name as well. This is important to help me with my ratio. So it's LiAlH4. And I'm going to multiply it by a ratio. So I know there's many ways you can do this. This is how I like to set it up because it shows your units very organized and clean. So in my ratio, which is a fraction, I'm going to put the moles of what I don't want on the denominator. So I don't want the reactant. I'm going to put moles of LiAlH4. That goes on the bottom. That means that this will cancel out mathematically. And the moles that I do want is my product. So that goes on the numerator. So moles of B2H6. So what numbers do I actually put in my ratio? Well, that goes into our balanced equation. So these coefficients here represent my ideal mole ratio. So that means that for every 2 moles of B2H6 that are formed, 3 moles of LiAlH4 are used. So they react in a 2-to-3 ratio. And when you do this calculation, I will get moles equals 0.0879, I'll round it. That's how many moles of B2H6 I have. Okay, perfect. So now that I have the moles of that, I can rearrange my mole formula to isolate for mass. So I know that mass is moles times molar mass. So the mass of the product will be the moles, 0.0879 moles, times its molar mass. So I'll use my Avogadro periodic table, and the molar mass of B2H6 is 27.6 grams per mole. And what I can see in my units, that moles will cancel out with moles, leaving my answer in grams, and I will get 2.43 grams. So this is how much product I can make when I have 5 grams of my LiAlH4. So the answer to this question is B. That's how we solve a stoichiometry mole ratio kind of multiple choice problem. I hope that helps.